Alright, in this video we are going to look at goal M.1.1 in the ATIT study manual for math. And what M.1.1 is, write non-negative fractions as decimals or percents or go the other way. So we have fractions, we have decimals, we have percents, and we're going to have to convert back and forth between these. And what I've also done too is I've renamed these goals. I have them based on what you'll see in your study manual, because if you take the practice test at the ATIT's website, they will tell you what goals you need to work on. So I think it's good for us to refer back and see what goals that we need to work on as we practice for the TEAS, and then if we take the TEAS and we have to take it again, it's good to know what goals to go back and look at. And that's how I'm going to label these videos. So we also have a calculator that we can use. Again, it's going to be a 4-function calculator, something that looks remotely like this. It won't be identical. I don't know if you'll have the memory buttons. I haven't seen the calculator that's included on the TEAS, but I know you will have a plus, minus, divide, and multiply. You will obviously have an equals button. You will not have a fraction button. You will not have a percent button, to my knowledge. So let's go ahead and dive into this. I'm going to definitely use the calculator to show you how to get some of these answers much faster, but I'm still going to kind of show you the nuts and bolts that really make the problem work the way they work. And one example here is you have to convert each decimal to a percent. Here's a way I can remember, here's a way that I teach students how to remember which way to move the decimal. So D to P, think of this alphabetically. D comes before P. And if you want to go from a decimal to a percent, you're going to move the decimal 2 places to the right. And then you also have to remember to tack on the percent symbol. If you want to go from a percent to a decimal, you're going to move the decimal 2 places to the left, and then you have to remember to take off the percent. You'll see what I'm talking about right here. First example, so convert each decimal to a percent. I know for a lot of nurses who are taking the TEAS test, your nursing instructors will stress to you about putting the 0 in front of a decimal. That way you don't overlook that decimal. It's not absolutely necessary, but do what your teachers tell you. That way a doctor will not overlook that decimal if you're filling out a medication, some dosage or something like that. So here we have a decimal. We want to convert it to a percent, so we're going from a decimal to a percent. Let's move that decimal 2 places to the right, and then we have 75%. Don't forget to tack on your percent symbol. So 0.75, 0.75 is 75%. We can also read this as 75 hundredths, because that place value of that rightmost digit falls in the hundredths spot. Same thing with this one. Move your decimal 2 places to the right. We don't need these zeros out front anymore, so 0.09 is going to be 9%. Again, we can read this decimal also as 9 hundredths, because the 9 falls in the hundredth spot, and that's the rightmost digit we have in our number. Same thing right here. Move your decimal 2 places to the right, so we have 263%. And a way you can read this decimal up here is 2 and 63 hundredths. I'm mentioning these place values here because that can help us when we go to look at fractions in a little bit. And then this last one right here, let's move it 2 places to the right. So therefore we have 65.24. Don't forget to tack on your percent. Now we can read this decimal right here as 6,524. And what place value does this fall in? Tenths, hundredths, thousandths, 10 thousandths. So we can read this as 6,524 10,000ths. But a lot of people just read it as 0.6524. But there is a technical way, and that's that way of me talking about 6,524 10,000ths. Now, something else on the calculator. Let's go ahead and throw that out there. Really what we're doing here, when we go from a decimal to a percent, all we're really doing, when we move that decimal 2 places to the right, so that 0.75, notice the calculator automatically throws that 0 out in front. But 0.75, if we multiply this by 100, notice we get 75. Anytime you multiply a number by 100, all you really do is move the decimal 2 places to the right. So that's where that 75% is really coming from. 0.09, that 0 there is very, very, very important, and this one may be important if your nursing instructors tell you to put a 0 in front of the decimal. But again, let's just multiply it by 100, and we get 9. That's really where we can write 9%. We're just moving that decimal 2 places to the right, which is the same thing as multiplying by 100. So 2.63 times 100 is 263, and then this last one right here, 0.6524, let's multiply it by 100, and as you can see, all we're doing is moving that decimal 2 places to the right. Okay, now let's come on down to the next set. Now let's go the other way. Let's convert each percent to a decimal. Well, that's where this D2P can help you. Remember, whether you go right or left, now we're going from a percent to a decimal, so we're going from the P back to the D. So we're going to move 2 places to the left, and now we need to remember to take off the percent symbol. So going 2 places to the left, we're going to go 1, 2 to the left. So therefore we have 0.427, and just don't forget to put the 0 out in front, that way you don't overlook that decimal. So 42.7% is the same thing as 0.427, and we can read this decimal as 427, what place value is that? Tenths, hundredths, thousandths. So we can read this decimal as 427 thousandths. Same thing with this one here, move it 2 places to the left. Now here, when I put that decimal right there, notice we have a gap right here. We have to put a 0 in that spot. So be careful with that one. A lot of people get that mixed up. They'll put 0.69, and that's actually 69%. We got to remember to throw a 0 in that spot. Throw a 0 out in front just to make sure we don't miss that decimal. And therefore, 6.9% is 0.069. Or we can read this as 69 thousandths, because that 9 falls in the tenths, hundredths, thousandths spot. And then this last one right here, let's move it 2 places to the left. Therefore, we have 3.7112. Notice when I move that decimal 2 places to the left, it goes between the 3 and the 7, and then I'm just including all my other digits. And for each one of these examples, notice the percent symbol has been dropped when we convert it to a decimal. That's very important. They're going to try to fool you on that maybe when you're converting from decimals to percents or fractions and all this stuff on the TEAS test. Now, what's really going on there? Well, remember how we multiplied by 100 up here to go from a decimal to a percent? Well, in these problems down here, we're actually dividing by 100. So watch what happens if I take 42.7, which is that percent I have there. If I divide it by 100, notice we get 0.427, which is exactly what we have there. And feel free to go check all these. 371.12, that's the percent. We divide it by 100. And notice we get 3.7112, which is exactly what we have right here in the calculator. All right, now, the dreaded F word, the fraction. How do we convert a decimal to a fraction? A decimal to a fraction, this is where place value is very important. So I'm just going to go ahead and underline the rightmost digit in each one of these problems that we're working out. And let's go ahead and identify the place value. This is the tenth spot. This right here is the hundredths. Notice I'm putting a little THS on the end. That's not the hundreds, it's the hundredths. And this is the tenths, hundredths, thousandths. So thousandths. Now, this number here, we see 10. I know we see tenths, but think of it as 10. Think of this as 100. Think of this as 1,000. These are going to be our denominators. So I'm kind of doing all 3 of these at one time. But I think it's a good way for it to go ahead and stick and sink into that brain. So the tenth spot, I put a tenth at the bottom. When you put a 10 in your denominator, you read that as tenths. Hundredths. When you put a 100 at the bottom, you read that as a hundredth. And then the same thing for the thousandths here. Now, all we can do is, since this 0 here, I know I told you it's important to write it down so you don't overlook the decimal, but really all we have here is 5. So that's 5 tenths. Well, let's go ahead and reduce that. We can divide the top and bottom by 5. So therefore we have 1/2. Whoops, I don't know why I put 2 equals there, but nonetheless we have 1/2 here. And if you think about that, I mean that's more of a basic kind of problem, but 0.5, 50 cents, you can throw a 0 there if you want to, but 50 cents, 0.5 is the same thing as a half. So now this one, the hundredths, we put the 100 at the bottom. This 0 here is not really that important because it's just helping us not overlook that decimal. And then we just write down the number 68 because that's what we really have up here. And what can we divide these by? Now you might say, well, let me go to the calculator and use the fraction button. Remember, we don't have a fraction button. But instead of you killing too much time, you can divide by something bigger than 2. But since both of these numbers are even, you're guaranteed to be able to divide by at least 2. So 68 divided by 2 is 34, and 100 divided by 2 is 50. This is a little lesson on simplifying fractions. I'm just going to slide this stuff over, and notice these numbers are still even, so we can divide by 2 yet again. and 34 divided by 2. So what do we get there? 17, and then 50 divided by 2 is 25. So that's as far as we can go with that. And just to throw that out there on the calculator as well, technically since we divided by 2 and we divided by 2, we can take 68 and we can actually divide it by 4. And notice we get 17 up top. And then we can do the same thing with 100. We can divide it by 4, and that is going to be 25. All right. So that's how we can simplify fractions, but it all goes back to the beginning of understanding your place values. Whatever place value it falls in, that is going to be your denominator. So the same thing here with this one. Notice this 4, it's not a 0. So what we want to write down here is 4, 5, 5, 4. Now notice we have a bigger number on top than we do at the bottom. Well, we're supposed to because we have 4 point something. We have more than a hole. We actually have 4 holes and about 4.5 holes. If you think about it, it's 4.5, 4.6, whatever. But nonetheless, here, let's just go ahead and use the calculator. Let's see if we can divide by something bigger than 2. So 4, 5, 5, 4. I'm going to divide this thing by 4. Let's see what we get. Okay, we can't divide by 4. Because we get a decimal. And we don't want to use decimals and fractions mixed together. So let's just take the 4554 and let's divide it by 2. And therefore we get 2277. So 2277. And then if we take 1000 divided by 2, we get 500. And just let me check some things. 14, 15, 16, 17, 18. I think this right here is as far as we can simplify it. I highly doubt you'll run into one this crazy. I just made these up on the fly. But nonetheless, this one right here will not, to my knowledge, maybe I'm missing a number, but I don't think we can divide by anything else. We can't divide by 2 because we have an odd number here. We can't divide by 3. I'll go ahead and throw the secret to 3 out there. If you can add up each individual digit in a number, 2 plus 2 is 4, 4 plus 7 is 11, 11 plus 7 is 18. Notice 18, I added up each individual digit. 18 is divisible by 3, so we can take 2,227, we can also divide it by 3, and notice we do get a whole number. However, look at 5 plus 0 plus 0. 5 plus 0 plus 0 is 5. 500 is not divisible by 3. Notice we do get a funky decimal there. So this one right here I think is pretty much simplified, and we can leave it as a improper fraction. Now, calculator, calculator, calculator. Convert each fraction to a decimal. Well, all you really have to do here, a fraction is none other than just division. So 17 over 20 is really 17 divided by 20. Now, I'm going to show you how to do these pencil and paper, but I want to go ahead and throw that out there, that really all you're doing here is really dividing. A fraction is division. So that one right there, 0.85. That's all we have to do there. I don't know why I copied that over. I could have just wrote it down, but nonetheless, 17 out of 20 is 0.85. 37 over 10. Grab your calculator. That's going to be 3.7. 37 divided by 10, 3.7. So I'll just write that up here. And then this last one here, sometimes you will run into a decimal that gets repeated. 4 divided by 9. We get 0.444444. So we can just write this as 0.4 with a bar over it. A bar over that number means it gets repeated. Now, how do we do these? You can skip this part if you don't really care about knowing where does this thing really come from. But nonetheless, I'm going to show it to you anyway, and I'll show it to you on these 3 examples. Fast forward if you're okay with just using the calculator and moving on to the next pieces. So this first one, 17 over 20. I always think of this as inside over outside because I'm thinking about some long division here. Inside over outside. What do I mean by inside over outside? 17 goes on the inside since that's my numerator, and 20 goes on the outside since that's our denominator. That's how you can always take a fraction, convert it into some long division, and now we can get our decimal. Now 20 will not go into 17, so I'm going to make this 170, but technically it's 17.0. So I'm going to throw a decimal up there. Now 20 goes into 17? No, so it goes into it 0 times. That's where that 0, throwing that 0 in front of a decimal so you don't overlook it. Now, will 20 go into 170? Yes, it will. If we take 20 times 8, that gives us 160, right? So, yeah, 20 goes into 170, 8 times, if we subtract that 160 that we get, because 8 times 20 is 160, we get a remainder of 10. And let's bring down one more zero. One more zero here, so boom. 20 goes into 100 how many times? 5 times exactly. And notice when we subtract, we get a remainder of 0. So look at that, 0.85. That's exactly what we got from the calculator. Pretty cool, huh? And you can do the same thing with this one. I'll tell you what, I'm going to show you this one here. Feel free to do some long division, but I'm going to show you number 3 as well. I don't want to make the video too long, but I would love to sit here and show you all these. I got some videos on my website that talk about strictly converting fractions to decimals using long division without a calculator, but nonetheless, we can use a calculator here. So let's do inside over outside. So inside is going to be the 4, outside is going to be the 9. And now since 9 won't go into 4, it goes into it 0 times. Let's remember this is, I'm going to think of this as being 40, but I'm bringing up a decimal. And let's see here. Well, what's 9 times 4? 36, right? That's as close as we can get to 40. So I'm going to say, okay, 9 times 4 is 36. Subtract, we get a remainder of 4. Let's bring in another 0 here. Boom. Shooting it on down, 9 times 4 is 36. Subtract, we get a remainder of 4. Do you see what's happening here? We keep getting remainders of 4 and we keep shooting down more zeros. Well, this is going to occur for the rest of your life. So that's to keep the boring details out. That 4 just keeps on going. That's why you saw that. Do I still have it up here? Yeah. The 4s keep on getting repeated there. All right. So a real quick way to convert a fraction to a decimal is to just divide it. 17 divided by 20, 37 divided by 10, 4 divided by 9. But long division will get you that same answer as well. And I think we got 2 more topics here. Yep. So convert each fraction to a percent. Well, here's the plus about me showing you the calculator. The first thing you want to do, step number 1, is convert fraction to a decimal. And we just did that in the last example, right? We just did that. And actually, these are the exact same 3 fractions. And this is what you're going to have to do to go from a fraction to a percent, in my opinion. There are other ways of doing it. You can put it out of 100 and stuff like that. But if you want one way and one way only that always works, convert your fraction to a decimal first. So these decimals are what I'm talking about, these answers that we got up here. So number 1 is going to be 0.85. Number 2, we already got these answers, 37 divided by 10, that is going to be 3.7. And number 3, when we did 4 divided by 9, that was at 0.444, ... Okay, now I know I put a bar over it a while ago, but trust me, I got a reason for writing out a few of these 4s here. So that's step number 1. What about step number 2? Once you get your decimals, which is what we have right here, you want to convert the decimal to a percent. And remember from earlier, like I think it was the first problem we did, D2P. And I also mentioned multiplying by 100. All we have to do is take this decimal and shoot it 2 places to the right. So once we do that, shoot this decimal 2 places to the right, we get 85. And don't forget your percent symbol. So 17 out of 20. Think about that. If you have 17, if you cut a pizza into 20 equal slices and you get 17 of those slices, you're getting 85% of that pizza. 37 over 10, this is an improper fraction, so we should have something that's more than 100% because we have more than one whole. We have 37 out of 10, 37 is bigger than 10, right? Let's shoot that decimal over 2 places to the right. Be careful here, we need to tack on a 0. So 3.7 is 370%. And this last one right here, moving our decimal 2 places to the right, D2P, decimal 2%. Therefore, we have 44.4, and I'm going to put a bar over that guy. You don't want to put a bar over the whole thing, but 44.4%. Now, you probably could round this thing, and you can just go ahead and say, hey, it's roughly 44.4. But I'm not going to talk about rounding here. I'll save that for another video. So that 4 does get repeated there. This kind of brings me to something else, though, to be careful with. Let me throw an extra example up here. Number 4. Let me do 7 over 9. 7 over 9. I know I'm kind of getting a little unorganized here. Let me just enter some of this stuff down. and drag these 3 examples here on down as well. And I don't know why I just did that. I want the example to be down there. All right, so number 4, that's 7/9. Tying this into it, because if we, I said I won't talk about rounding. Well, I lied. I need to talk about it a little bit right here, just in case you run into a problem in your study manual or in your studying before you get to the rounding piece. Well, first of all, 7/9 is going to be equal to 0.7 repeated. And just to show you that, we can take that fraction. Remember, a fraction is nothing but division. So when we divide it, look at what the calculator is going to spit out. The calculator is going to round that last digit. And since there's a bunch of 7s that occur forever and ever and ever, that 7 right here is telling this other 7 to go up to an 8. Whereas a while ago when we did 4 divided by 9, all we see is a bunch of 4s, because a 4 does not round a number up. A 4 will tell whatever number that occurs in front of it to stay the same. And maybe you are somewhat familiar with rounding, so maybe that makes a little bit of sense. If not, it's coming up in a future video. But I tell you what I'm going to go ahead and do here. I'm going to go ahead and say, well, this is the same thing as 0.7777 ... We want to convert this to a percent. So we've taken our fraction, 7/9, we've converted it to a decimal, and now let's take that decimal and convert it to a percent. So moving the decimal 2 places to the right, we have 77.7 with a bar over it percent, or we could say this is pretty much 77.8% if you were told to round to the nearest 10th of a percent. I hope that makes sense. Again, rounding is coming up more later. I highly doubt they're going to fool you and try to put both of these as 2 separate answer choices unless they start talking about rounding to a specific spot. And rounding is going to be one of our goals that we focus on later. And now finally, the last 3 examples convert each percent to a fraction. What you want to do here is you want to take a number 1, drop the percent symbol, and a percent is always something out of 100. Always out of 100. Number 2, a percent is always something out of 100. So I'm writing 37.2 and I'm putting it over 100. A percent is always something, that percent, out of 100. So 8/100. Now we need to simplify these fractions. All these simplify a little bit differently. Well, this one definitely, because we have a decimal mixed into it. But thinking about these 2 guys right here, what's something we can divide them both by? Sure, you can divide by 5, but think about quarters. We can divide by 25, right? 75 divided by 25, well, I know 3/4 gives me 75 cents. So 75 divided by 25 is 3. 100 divided by 25 is 4. 75%, think about that. I hope this makes sense. 75% of something is 3/4 of that something. Take a pizza, cut it into 4 equal slices. You're cutting it into quarters. 3 of those quarters, 3/4, is going to be 75% of that pizza. I'm going to come back to this one at the very end. Let's go ahead and do this guy right here. We can divide both of these by 2, or we can go ahead and divide them by 4. 8 divided by 4 is 2. 100 divided by 4 is 25. And to kind of tie this all back in together, check this out. Remember earlier we talked about fractions, and then we were converting the fractions to a decimal, and then we were converting the fractions to a decimal to a percent. Check out this fraction right here, 3 divided by 4. Notice we get 0.75. That's that 75% because we move the decimal 2 places to the right. All these topics tie in together. The percents, the fractions, and the decimals. I hope that makes sense. This last guy right here, 2 divided by 25. 2 divided by 25 is going to be 0.08. Remember, move the decimal 2 places to the right. Bam, there is your percent. All right, we could, 0.08, I did 2 divided by 25. It's the same thing as 8 divided by 100. It's just that we had to simplify. We had to simplify this fraction here. That's probably what you're going to have to do on the TEAS test. So throwing that out there. Now, what about this one? What do we do with this guy? Well, one thing we can do, I'm going to show you 2 ways, is we can make this number up here a whole number as long as we move the decimal the same number of places at the bottom. I had to move that decimal one place to the right to make it a whole number. Well, let's move this decimal. You don't see one, but we assume it, and yes, it is going to be at the right end of that number, so we have to tack on an extra 0 there. So it turns out, check out on your calculator, if I type 37.2 and I divide by 100, I'm typing in this fraction. Let's pay attention to the decimal that we get here, 0.372. All right, well, earlier I was talking about place value. 372 what? Remember that last digit, the 2? That falls in the thousandth spot. So 372 thousandths is the same thing as 37.2 hundredths. That may sound kind of crazy, but look, again, I did the 37.2 divided by 100 and I got this. Well, watch this here. 372, I didn't use my decimal. If I divide it by 1,000, we're going to get the exact same decimal. And now from here, we do want to divide these things. Can we divide by 4? 372 divided by 4. Yes, we can. So I'm going to divide the numerator and denominator by 4. And I forgot what I just said it was, 93. So 372 divided by 4 is 93. 1,000 divided by 4 is 250. And can we divide by anything? I don't think so. So we're going to let it roll with that. I may have messed up on my simplification, but I don't think anything goes into this. 2 won't, 3 won't go because that little shortcut I gave you with 3 earlier in the video. 2 plus 5 is 7, plus 0 is still 7, and 7's not divisible by 3. No even number will divide into these. So I'm pretty sure this is as far as we can go with that. And you know, looking at it like that, that is crazy, but yes, we have covered M.1.1 as a whole. We've looked at fractions, decimals, and percents, and going back and forth between these different techniques. And there you have it. That is goal M.1.1 for the math portion of the TEAS test. And that is it for this video. I hope it helped.